Welcome, Algebra 2. So today we're going to give you an introduction to logarithmic functions. So we have exponentials here, and something called a logarithm is its inverse. So let's talk about something that you know. We have addition, and its inverse is subtraction. We have multiplication, and its inverse is division. We have exponents like this, like x squared, and what will undo an exponent is a radical. Well, when we have like 2 to the x, this is an exponential because your variable's up in the exponent. And the operation that will undo exponentials is called logarithms. All right, so what would it look like? So if you have log base 2 of 8 equals something. All right, so this says the mantra is the log is an exponent. The log is an exponent. So we're trying to figure out, if I have the number 2, what should I raise it to get the number 8? So that would be the same thing as saying 2 to the what power equals 8. Well, that would be 3. So 2 to the third equals 8. So therefore, log base 8, or log base 2 of 8 equals 3. So the log is the exponent. It says 2 to what power, that would be the third, equals 8 right there. So here we have what you would frequently see. This is the formula how to go back and forth between exponential functions and logarithmic functions. So a lot of you like to color code things. So the exponent, I shouldn't have started with that. You need to start with the base. I'm being silly today. So this is a base raised to an exponent equals x. So when you have a logarithm, you read this as log base b of x equals y. So this base and this base are exactly the same thing. So when it comes to the other parts, the y is going to cross and go to the other side of the equation. And then the x crosses and goes to the other side of the equation. So if you like color coding things, that's how you would color code it. All right, so we are going to practice writing logarithms in exponential form. So once again, this is log base b of x equals y, and in exponential form, it's b to the y equals x. So if you go through and if you were to label it, the 2 is your b, that 16 is your x, and the 4 is your y. So this says I would have to raise 2 to the 4th power to get 16. So the base is the 2, the 4 comes up to the exponent, and it equals 16. So while you're trying to get used to the logarithmic form, you should certainly be comfortable with the exponential form. So you should be able to go in your calculator or mental math, 2 to the 4th equals 16, and yes, when I put that in my calculator, that is a true statement. So if you are moving from log form to exponential form, and if you had accidentally put in there, I don't know, 2 to the 16th equals 4, well, you should recognize that that's a false statement. So this should always be something that you can put in your calculator and check. Here I have log base 4 of 1 equals 0. So I have my base is 4, that's my x, and that's my y. So that means that 4 to the 0 equals 1, because the 4 is the base, and then the 0 comes to the exponent, and the 1 goes to the other side. 4 to the 0 equals 1? Yep, that's absolutely a true statement. Here there's your b, your x, and your y. So this says log base 12 of 12 equals 1. So that would mean 12 to the first equals 12. Yep, that's a true statement, because any number raised to the power of 1 equals that number. Here the 1/4 is your base, that's your x, and that's your y. So this says 1/4 to the negative 1 equals 4. We haven't done a lot with fractions, so you might need to put that in your calculator, but as soon as you do, you would find that that is a true statement. I want to go backwards now. So this is b to the y equals x. Your log is log base b of x equals y. So the 5 is your base, the 2 is your y, and the 25 is your x. So in log form, I have log base 5 of 25 equals 2, because the log is the exponent. So here you would have log base 4 of 2 equals 1/2. That's your base. So this says log base 4, 1/64 comes over, that's supposed to be the denominator, equals -3. The 10 is my base, so I have log base 10 of 1 equals 0. I'm going to skip around on this because we've changed a few things over the years. What I do want to do is common logarithm. A common log is a log with a base of 10. We do that because that is what your calculator is set to. It is the most common one. So if you see something like log x, you need to know that that's the same thing as log base 10 of x. So when there is no base showing up, you need to know that the 10 is implied to be there, because that's the most common. Why? I don't know, because we get lazy in math sometimes. Like instead of writing 1x, we just write x. Sometimes if it's the most common thing, we just drop it. I'm going to jump down here and we're going to do the change of base formula. So we have this problem, log base 5 of 125, and we would like to figure out what does that equal. So there are many ways I can teach it. I'm going to use the calculator and the change of base formula this year. The change of base formula says log base b of a equals log a divided by log b. So your calculator, most of them aren't set up to handle a log base 5. It only knows how to calculate log base 10. Oh dear, caps are flying. Okay, so when you have this, we're going to rewrite it, and when we rewrite it, there's no base that I wrote down here, so I'm changing it to a base of 10 so I can use my calculator. So this b is kind of trying to drag it down, so that one goes down to the denominator. So when I want to evaluate this right here, that base is your b, and then the 125 is your a. So when I rewrite this, I have log of 125 divided by log 5. All right, let's pull out the calculator and try not to get a shadow. There we go. All right, so the log button is up here on the calculator, so you're going to hit log 125. Super important, you have to close the parentheses, otherwise it messes up the order of operations. This is a fraction, which is the same thing as a division problem, so we're going to go divide log 5, close parentheses, hit your equal button, and we find that that is 3. Let's do one more. So log base 64 of 1/32, what does that evaluate to? So the 64 is your A. No, it's not. That's your base. That's your B. 1/32, that's your A. So I have log of 1/32 divided by log of 64. All right, so in your calculator, go log. I would probably use the division button, 1 divided by 32, close parenthesis, divided by log 64 equals. All right, so we generally don't like decimals in this part of math. So we need to change that to a fraction. So I'm going to hit my second and this probability button. So the F to D button right there, that will change it into a fraction, and we like -5/6 best for that answer. You should check the notes for the next two. Thank you so much.